we done now? Why not?
We have to find like
Okay, in general, the direction. Okay, so trying to find this angle right here. How do we find that angle? I know the adjacent, I know the opposite, I know the hypotenuse. Okay, now preferably, there's rounding off as we go. This 35.9 I assume is rounded off. The hypotenuse is definitely going to be rounded off. So when you are working through it, the general recommendation is use the two with less rounding involved. On a quiz or test, whichever way your mind's working at that moment is fine. But the general preference is to use these two values and not the hypotenuse. But if you did, I probably would not notice the difference on a test or quiz. On the lab, I would, but test or quiz, no. So we end up with, I know that the tangent of that angle is the opposite over the adjacent. It's going to be equal to 35.9 over 24. In other words, theta is the arctan of 35.9 24ths. That is not a sufficient answer. You have a calculator, use it.
$56.24.
56.24?
That's what I got.
Did somebody just say it?
Degrees.
Yeah, degrees. So what's my final answer? We've done even more of the hard work. Let's actually express the answer. What is the final velocity? Let's get you started on that one. VF equals
43.18 meters per
43.18 meters
second.
per second.
At 56.243.
56.24. There is a mistake there. What is wrong? I'm assuming the numbers are calculated correctly, so it's not an issue with the number itself. Pardon?
Direction.
What about the direction?
We need to specify what direction it's going, so it should be positive I hat.
No, not, in polar form, we're not using I hat, J hat.
Negative 43.
No,
Okay,
Negative
negative
56.
56.
yes, negative 56. If you just left it at positive 56, that means it's hitting the ground at that angle right there. But it's hitting at that angle, so the convention is that it's a negative angle. Or if negative angles bother you, add 360 and do it that way. 360 degrees. All right, that is an answer that has a magnitude, it has a direction. Assuming calculations are done correctly, we are done. However, we could have done it much more simply. If we'd done rectangular notation, V final equals 24 meters per second I hat minus whatever that number was, 35.9 meters per second J hat. Done. We'd already had the numbers. Rectangular form was saw it somewhere. I'm not saying what we did with the polar, it's good exercise, you should be able to do it, but just emphasizing you don't have to. If I don't specify, you don't have to do it in polar. Textbook often will say, what is the magnitude and direction? In essence, it's looking for the polar form. But either one is an acceptable answer. And some people just like doing trig, and so I'm not gonna count against you for doing that. Years ago, my wife and I were both teaching math at high school for different high schools. And we were at a restaurant where they had crayons and paper for tablecloths so that you can.
Macaroni grill.
It was not macaroni grill, but it's that type thing. And so we were talking trig, and so we trig formulas all over the paper. And one of my students walks in, just giving the impression that that's all I do is talk math. All right, questions? All right. We're all experts at this now. Let's make it harder. At this point, internet, so if you need to refer to it, you can. Back to the cliff. Now we'll keep it at 50 meters. It is being launched at let's keep it at, let's make it 53 degrees. 53-degree angle. It lands. Not sure it matters. Make it 120 meters away. Not to scale. What is the initial speed? So at this point, it's just all variations of a theme. We've gone through it, but it's just a matter of what you're given and what you're not given. And so you're still working through it. Now, there are some forms of the problem. For instance, if I told you the initial speed but not the angle, which is probably the most difficult of these problems where you're trying to find the angle. Well, let's figure out what we know. As with any problem, let's establish I hat, J hat. In the videos, I might not label them I hat, J hat, but horizontal, vertical. So delta X, VI, VF, A, and T. All right, there are a couple things that are the easy ones. So get a chance to show off just by giving me an easy answer first.
Displacement in the IR is 120 meters.
Negative 50 meters.
Acceleration, J hat is negative 9.8 meters every square. And zero in
All right, they're the easy ones. Now, we got that 53-degree angle, but we don't know what V is. What can we do with that? If I told you V, what would be the horizontal component, or how would you find it? Yeah. So whatever V is, it's V times the cosine of 53 degrees. And vertically, V times the sine of 53 degrees. So now, we're solving for V. I've got 4 equations from which to choose. What equation do you think might be a good one with which to start? If we pick the wrong equation, then all we've done is spend time. It's not like, it'll become obvious, I hope, whether it's usable or not. So someone take a shot at it. What equation do you think we probably should use?
Same one we've been using.
Yeah, that's probably a good start. So I'll do the I had equation. So I have 120 is equal to V cosine of 53 degrees times time plus 1/2 0 time squared. So that tells me that 120 is equal to Vt times the cosine of 53 degrees, which is about 0.6. That's why I picked 53 degrees. So Vt would be 120 over 0.6. 200? 200, okay. I don't know what V is and I don't know what T is, but I know that the product is 200. Let's do our J-hat equation. My J-hat equation is -50 equals V sine of 53 degrees times time minus 4.9 t squared. So I have -50 is equal to Vt times the sine of 53 degrees, which is about 0.8, minus 4.9 t squared. Again, I don't know what V is, I don't know what T is, but I do know what V times T is. That's 200. So I have -50 is equal to 160 minus 4.9 t squared. This now is a much easier problem to solve. So -210 is equal to -4.9 t squared. Divide by -4.9 minus 4.9. No, divided by -4.9. And t squared is equal to 40 something. Someone's gonna tell me what it is. Or we're just gonna stare at each other.
42.86.
And therefore, at the time,
6.55.
6.55.
And negative. Seconds.
Yeah, mathematically there is a negative, but,
Right, yeah.
all right, so I now know the amount of time it is in the air. I need to find the speed, because that's the original problem, was what's the initial speed? And, well, I have a formula, I know what V times T is. So that's gonna be V times 6.55. So whatever 200 over 6.55 is. 27-ish?
30.53. Meter second.
Did you say meter second?
Meters
or
per second.
Per second, yeah. Didn't know if you're suffering from the anti-AIDS disease.
I'll talk real fast.
In my hearing's not up to what it used to be. All right, so we now know the initial speed. We can test it by doing the exact same thing we did just a moment ago, because I now know the initial speed and direction. In other words, I know the initial velocity in polar form. questions to hear. Okay, let's make it harder. We'll just make that 30 meters per second, and I know one of the angles should be somewhere around 53 degrees, because we're basically, it's almost the same problem. However, there are probably gonna be two answers here. So we need to work through that. The 120, the -50, those are the same, the 0, -9.8 are the same. What's different here is this part. This is going to be 30 cosine of theta and 30 sine of theta. I do consider this to be the hardest of the projectile motion problems. I figure if we get through this, then all the rest of the problems will just seem like child's play. What equation do you think we should start with?
Same one.
Yep. All right, so I got my I hat equation. I got a 120, this is my I hat equation. 120 equals 30 cosine of theta times time plus 0. So I end up with 40 is equal to t cosine of theta. My J hat equation. I have an equation here with two unknowns, so I need at least another equation. If I have two unknowns, I need two independent equations. So I got -50 is equal to 30 sine of theta times time plus or minus 4.9 times squared. I have two equations, two unknowns. It should be solvable. Some of you have calculators that will make it trivial, but I'm going to assume that you don't. How do you solve a system of equations? Well, what is one technique for solving? I have two equations, two unknowns. What do I do?
Elimination.
How? What do you mean?
Put them on top of each other.
So -50 equals 30 t sine theta minus 4.9 t squared. Okay. Now what? If these were ordinary, you know, we didn't have a trig function in there, that probably would be, that might be one of the easier ways of doing it, but with trig functions in there, it becomes more difficult. So what's another technique?
Could we set that 40 equals t cosine theta to t equals whatever?
Solve for t? A substitution, all right, so t equals 40 divided by cosine of theta. Plug into here, I get -50 equals 30 times 40 over cosine of theta times sine of theta minus 4.9 times 40 over cosine of theta squared. I now have an equation with a single variable. Unfortunately, it acts like it's got two variables here because sine of theta and cosine of theta, it's not like I can easily pull the theta away from the sine or the cosine. But let's go ahead and simplify what we can. I got -50 equals 1200 times two approaches. we can exploit knowledge of trig, or we can, well, let's exploit the knowledge of trig. I have sine divided by cosine, which is, I know somebody in here knows it. What's sine divided by cosine? I just didn't hear what you said.
I don't think it's right.
What letter did it start with?
I was gonna say 0.
Oh, yeah, not 0. That would be convenient.
Is it the, SEC? That's,
Secant?
yeah, secant.
The
I
tangent,
missed what he said.
tangent?
Yeah, it's tangent. Sine divided by cosine is tangent. So it's looking like this is probably not the best technique for people in here. I have 4.9 times 40 squared, whatever that is, 4.9 times 40 squared, or .9 times 1600 over cosine squared. All right, I'm gonna force this one through. All right, so let's do a quick review of trig functions. Find my hypotenuse, and I'll label that O for opposite and A for adjacent, and I'm looking at this angle right here. The cosine of theta is going to be the ratio of the adjacent to hypotenuse. This is what now is being taught as SOHCAHTOA. Sine of theta is the opposite over the hypotenuse. Tangent of theta is the opposite over the adjacent. So if I have a right triangle, the ratio of sides are expressed as the cosine, sine, and tangent. Keep that for now. If I do sine divided by cosine, so sine of theta over the cosine of theta, that's going to be the opposite over the hypotenuse divided by the adjacent over the hypotenuse. In other words, the opposite over the hypotenuse divided